So who is going to help? I think Valerie, can you help me? Which one will work here? You did it, I think, last time, right? So whenever the okay, quick. Whenever the this is homework 7.2. Let's really get. We know the proof. We have done so many proofs. Now let's do the work. So there is a 17 and a 12. Somehow you want to split 17 into. We want to use this a plus b or a cosine a plus b or sine a plus b. Right now there is a cosine, so naturally I have to think of this, right? And then 17 is, what are the option? 1, 17. Yeah, I correct. This is wrong, right?
Yeah.
What mistake did I do? It's 1 and 16 and 2 and 15 and 3 and 14. So this is what it should be, 4 and, so likewise you can just think in mentally and decide, pick any two, so that you want to make sure, if you have, just imagine if this is 4 and, what was this? 13. Now, if you pick this will not help, you know why? What is the denominator here? 12. So if there is a denominator 12, 4 and 12 is okay, but 13 and 12 no number divides, so that won't help us. So that's the trick. Okay. So which one did you pick last time?
We did 9 and 8.
Okay, so the question is why 8 and 9 is because the 8 and 12 there is a divisor, right? So there is some number that divides both of them, and 9 and 12 also there is something that divides. So that's how the goal is. So let's do this. This equals cosine of instead of 12 you write it as 8 pi plus 9 pi. And can I separate this directly one skipping one step, or you want to write all everything? Okay, is this fine? And then you use you can use a plus b divide by c is a over c plus b over c. Agree? Yeah, it's like you are separating the denominator. You break it up. So split this here. So this is cosine 8 pi divided by 12, and then there's a plus sign, 9 pi divided by 12. Agree? Here you go. This is for you and Valerie. I think your parents have to sign and get it on Monday. Now, anyone just intervene and help me to. So let's do it together. How do I reduce this? How do I reduce this? 8 and 12. What number divides 8 and 12?
2 pi over 3.
Agree? Everybody agrees, right?
And then it would be plus 3 pi over 4.
So 3 goes for both at 3 pi over. Okay? So we are getting a comfortable kind of a number, and you know pi by 6, pi by 3, pi by 4. By now, we should not even check those things, we should be knowing the answers. Now, what do we do next is important. Now, this is like this is that, oh my red marker is over. So this is the, I think I used the red color, right? This is A, correct? And this is the blue color, blue. So as I do, you can also do it. So this will be, okay? So cosine of the first. So cosine of 2 pi by 3, okay, times cosine of the second. Oh, Nathan, you want to speak something quickly, whatever you were supposed to say?
I'm asking her for help.
With this one? Oh, you already reached that step and say, okay, well, you already wrote that step, I think. Okay, I know, I knew that. Because it's not difficult now that you kind of, even though you missed it, but you missed those identities before a lot of stuff. This is actually for Mondays, which was, pending. And then minus, so for cosine, the plus changes to minus. So that's the big. You need to take care of that. And then cosine, sorry.
Fine.
So sine of the first times sine of the second, right? So that's 2 pi by 3. And the other one is 3 pi by 4. So the question is, now we are back to, how do we figure out what is this answer? So some of you must have forgotten. You remember the best is you need to know which quadrant is that. So in order to know the plus and minus sign, we need to know the two things. One is this chart is required, and which quadrant what is positive, right? I don't think I have that. I don't know where I misplaced that. Or add sugar to coffee. You can remember. Oh, here it is. So what is 2 pi by? So either this or this, right? Correct? Now the first one, which quadrant? What is 2 pi by 3? So what I supposed to remember is 2 pi by 3. If you get confused, it is 120. Agree? That's fast. Your mind should be doing this work quickly because pi by 3 is 60. And then it's 120. So which quadrant are we talking about? Here, correct? So if it is the second, both cosine sine. Cosine negative, sine positive. So the first part is 100% this is plus, right?
Yeah.
Cosine is positive or negative?
Negative.
Negative. So cosine is negative. That takes care of, this two helps us to identify, this two which you see, that helps us to know minus or plus. That's all it is. Now I'm going to take this off because I already put minus sign. See? So you're back to cosine 60. And what is cosine 60? Root 3 over 2.
Oh, no, cosine. Sorry.
Oh, sorry, yeah.
Half.
Even I got confused. See? So it's half. Agree? So cosine 60 is half. So that takes care of the first part. Is that okay? And then times. Now I'm putting this back. This was 2. Now where is this 3 pi by 4? Second, right? So it's 45, 45, 45. Back to second quadrant. So again cosine is negative, right? And I'll take this 3 off. So what is the answer of 5 by 2?
Root 2.
It's not difficult. It takes a little while to get it. We did finish this a long back, but now you may have forgotten. That's why I'm writing. Then minus, what about sine? Now, this is again in the second quadrant. I just write here second quadrant, and this is also the second quadrant, right? So 2 pi by 3 sine. And if you look, this sine is, remember always, first is cosine, the second is sine. The cosine is negative, sine is positive, correct? SIN, when I say sine. So this is going to be positive. So what I'm going to write is, put it like this. Let's write it. So this is positive. Both are going to be positive. Agree? So what is sine 60? So I'll take off this 2 and just think of what is sine 60? Root 3 over 2. That's all it is. Okay? I'll put back. Take off this 3 and it is like sine 45. Root 2. Yes or no? Okay. And then finally it's just kind of a little work. 2 negatives makes it positive, and 1 times root 2 is, so this is plus root 2 over 2, and that will be minus root 3 times root 2. We can put under the same root sign. I'll try to skip one step there. And your final answer is, the denominator is same, so write it exactly the same, and that's it. Finished, right? Make sense? Any question? Now remember, if you understand one of this, no matter what 17 or something, they may give you any stupid number, you just see which 2 number helps. Is that okay? Let's do a second problem. Okay, I may have gone a little fast here. What I did is I tried to skip this plus. This 2 I multiply, right? Yes or no? That gives you kind of. So square root of 3 times square root of 2 is square root of 3 times 2, and that is 6. Agree? Let's go second. Next problem. The only change you'll see in the second problem is 10 minus 5 by 12. So this is 10 tangent of minus. So how do we write this part? I need your help, assistance. Hugo, would you like to share?
What was that?
Now, just because there is a minus, it's like little hard, right?
No, so it's 3.
3, 2? Oh, you are taking minus 3 and minus 2? You can, but I want one of them to be minus and other one is plus, so that it should be like the sine A or 10A plus B, because we have a formula also for, what is the formula for 10? 10, yeah, there is the A plus B and A minus B also, right? So that's the goal, to somehow use one of them. So this we'll put it like a plus and minus, but the other one I want you to keep, how do I say this? You know what I'm saying? Don't, yes, me?
Sorry for the.
I'm getting some money.
No, I came to the check.
Mhm. Okay, Rico, help me, what do I do with this? You try to pick two angles. Can you use this trick? If there is a minus, what do you do with it?
It goes in front of 10.
See how we, of course, you can do without this also, but now that we are like applying everything that we have, so 10 of negative 2, just take it out. So this is same as minus tangent of pi by 12, agree? Yes or no? And then you know what is 5, which numbers are better? Is it 1 and 4?
2 and 3.
2 and 3 is the best. Okay, so you can pick this one as minus tangent of 2 pi by 12. Can I write directly like this? Now that we know, right? See, I skipped one step there.
And then it would be 10 pi over 6
Yeah,
plus pi.
exactly. You try to reduce it, right?
Yeah.
So last time you guys came on the board, and thank you so much, appreciate. So this is, you can reduce this 6 and this 3 goes 4 times, right? So tangent of pi by 6 and pi by 4. Now that you have, this is like your A, correct?
Yeah.
And the other one is like a B, correct? And then you know what to do. So the formula says, this minus, be careful with this minus, which is, because you are applying formula for tangent, I'll put a bracket like this, just to make it nice and beautiful. To organize, this is called organize. So the tangent of A, so tan of A, and the A is the pi by 6, plus tangent of the B, which is pi by 4, and the formula says 1 minus, you remember, right? Tan of pi by 6, and times this thing, tangent of pi by 4. Agree? Are you guys get a hang of this?
Yeah.
Yeah, I know, that's why all this takes a little while to get a hang of it. And then you know what is 10. So this is straight, you don't have to break your head, like, which, because they are already acute, means the first quadrant. Now this is 30 degrees, right? So this is like a 30 degrees, this is 45 degrees, so you know the answers for 10, 45. What is 10, 30?
Square root.
Now be careful, this is where students make mistake, okay? Because there's a fraction there. So 10, 30, how much is that?
Square root.
Do 3 by 3, agree? Plus 10, 45 is 1. And 1 minus 10, 60 again is root 3 by 3. And then 10, 45, okay? So now, now what? Now be careful, this is root 3. And I'm gonna skip one step to show, there's a 3 here, so why don't I multiply 3 and 3 like this? Is that okay? You know the reason? Because there's a 3 here. So you want to make sure you have the same denominator. And then multiply here also 3. So they both are denominator. So kind of skipping one step there. So this will be equal what? So the top one will be square root of 3. The denominators are same, so this is 3. And the numerator will be square root of 3 plus 3. Is that correct? So now you don't need this, right? Now that you know all this, correct?
Exactly.
Huh?
Yeah.
It took how many months? 2 months? Just to remember this. Actually, in India, when I was teaching 16 years, we make students to write this at least 50 times on the paper. Yeah, 50 times. And as they write, and just remember. It's just practicing, basketball, go on throwing from one spot, and finally you get it. You know what I'm talking about. Practice is the best teacher. You just go on doing the same thing, it becomes easy. Why are you smiling, Hugo? That's true, right? Huh? There's a song, Sultan of Swing by Dire Straits, okay? Now this song, if you see the guy who is singing Mark Knopfler, when he's playing the lead also, and he's singing also, this is 1986. Can you imagine those days that now the rap music is come? It's almost something like that, but he's singing like that. But the point I'm saying is, I wanted to sing that song for karaoke somewhere, from pub anywhere. So I wanted to sing and I practiced. It took me so many. The other songs are so easy to practice. That song was so difficult because of the words. Which song is that Levitate by Dua Lipa? You see that song, you see how the words are so fast? You can't just get it that easily. You have to practice it so hard. You know what I'm saying? You know what I'm saying? So I was just trying to figure out that part. I said, oh my God, this is like so quick words. Anyway. And some songs are so easy, like they exactly go with the beat, like Ed Sheeran and, which song is that? I forgot, yeah, there's a song, The Legends or Ed Sheeran, one of those songs. You know what I'm talking about? Name one of the songs, Ed Sheeran's best song.
I don't know any of the names of the song.
Mathali, you know? Bianca?
By who?
Ed Sheeran, or The
Red
Legends.
hair?
Huh?
The one with the red hair?
Yeah, I think, is he red hair? Not blue hair?
I think Perfect is the one.
Yes, that's the one, perfect. How it starts? I found a woman.
Oh, yeah.
I mean, those songs are easy. You can know the words just flow. But some songs, like that, what she's saying, I don't know. And that calm down is my crazy. Like his accent is like, you know what I'm saying. Anyway, point I'm making is some things are easy and some things are so stupid like this. So the only thing you be careful with like that kind of thing. Because the square root 3, then there's a fraction. She's just looking at me. What happened? What were you thinking? Oh, she said, Bello, can you just finish this problem and you just talk so much? Okay. So this one is the 3, correct? 3 minus, I'm writing this is root 3 straight. So it is like 3 minus, so skip the step and just write 3 minus what? Anything strikes you, the trick, rebellious trick? Do you see the denominators are saying? Do you have to use this, keep, change, flip? You want to do this? Can we avoid this? How do we avoid this? They are the same. Gone, finished. It's so simple. I did forget about this minus sign which is here, so you better put a minus. Correct? So this is root 3 plus 3, and I'll just write 3 minus root 3. Or you can just distribute this minus and say this is minus root 3 and minus 3 over 3 minus root 3. Is that okay? And that's it. You can keep it like that. They didn't ask you exactly. Of course, sometimes they ask question about can you rationalize. You don't want the root sign, so then you have to, okay, let me multiply the opposite of that conjugate decorator. So that way, if you do this, the bottom one will be 3 is 3 squared, and you square the other one. So you try to avoid, and then you multiply these two things. So a lot of work, but you don't have to do that. That's only if you don't want the square root in the denominator. Third problem. What is that third problem?
Cos 4 times 5, cos 7 times 15.
Oh, so now comes those are really nice problems. It's like undo those. You are going to undo those formulas, the compound angles that we learned last time. Can you try at least what is A and B there? Think of A and B. Which one is A? Red color. Which one is the blue color?
4 pi over, 4 pi over 5, that would be it.
So you already know the answer, right?
Yeah.
Natali is thinking. What the hell is going on? You're thinking of that? That's so cool. That's nice. This is, Natali, what does this mean? Sometimes we want to get an answer without the radical in the denominator. You have to call it, this is called rationalizing the denominator. Just do the conjugate of this, which is that kind of thing. And you do, of course, you have to use the FOIL method first, outer, inner, last. Yeah, I mean, there's a lot of work there. It's not easy. You see, you multiply this, then you multiply this, you multiply this. You know what I mean? And the bottom one will be 9 minus, this root will cancel with the square, and it will be like just a 3. 9 minus 3 will be 6. The bottom will be 6. I mean, that's like you can do it at home, not now. Let's move on. So, third problem is cosine of 4 pi by 5. Anything strikes you when you look at it? What is that A, B? I want you to really get that A and B here. Okay, the red color A. Do you see this? Nobody's saying yes.
Yeah, it is.
Okay. So in the back of your mind, you're thinking that the B is this part, right? Agree? And then this one is cosine, cosine, and sine, sine. So which formula should help you?
It's cos A.
Cos of
A
A plus B or A minus B?
minus
A minus.
Very good. I'm so glad you got it. Ah, so simple now. So therefore this will be using, you undo the formula, right? You already know this is cosine A, cosine B, plus sine A and sine B. So all you do is you want to go backward, right? Sometimes they ask this question like this. I'll tell you. They give you like cosine of 40, cosine of 10, plus sine of 40, sine of. So that could be a question. Can you just tell me mentally what is this answer? Of course, this I'm not writing there just because that looks stupid because of this, all that pi thing. This looks beautiful because, hey, that's 40 degrees, 10 degrees, and so this is like A. Got it? And the other one is what? So the other one is B. Correct? Can you mentally tell me so quickly what is the answer? Cos 40 minus? Agree? What is that? 40 minus 10. Correct? And what is cos 30? No, the value. There's a chart right there. Cosine 30.
Just go root 3.
See, over done. I don't know whether they gave those problems. We'll see. That's just like me. They could make up. You can make 100 problems like this yourself. Okay. I use 40 and 10. The question is, why did I use 40 and 10? Because if you subtract 40, 10, you get 30, right? 30 is a good number. That's how you play it. Trick. Or they could have given addition also to make it 30. You could have used like 20 plus 10. Changing this minus to plus. You can change this to minus and write this as 20 and this is 20. Can you tell me what will happen now? A is 20, B is 10. So you just put 20 plus 10. What is 20 plus 10? Same thing. Anyway, bottom line, let's do this. This is cosine. So what should I write? Cosine of the A. What is A? 4 pi over 5 minus
7 over 15.
Is that okay? And then you try to, now be careful this is 15 and that is 5, right? So what do you multiply to get that 15 over here? Yeah, multiply 5 and divide. So not 5, 3. You need to get a 15, right? So you multiply 3 and, so that will be cosine 12, right? So this is 12. You're multiplying. So 3 times 4 is 12. So 12. Can I skip one step here and write 15 because this is 3 times 5 is 15. So we'll and then 7 pi. Is that okay? So what is that answer? 12 minus 7 is how much?
5.
Nobody's cosine of
It
5.
would be 5 pi over 15, which would be converted to cos of pi over 3, which equals 1.
There you go. Did you start liking it now? So not difficult, right? So kind of, I really Friday today, so that when you walk out, you say, oh, we can do this no matter what that is. Let's go. The other one you use A minus B formula. Can you try the next one, the fourth? Jaslyn started liking this problem, huh, Jaslyn? Right? Why? Kind of cool, right? Just play around with them.
Mr. Volo,
Huh?
can I get the packet?
Nobody gave me. Okay, wait, first, you use this one, mine, because I don't know where is my packet. Just put that in order. Do you have that, Bianca?
Yes.
It's easy, just
So what do you do? Let's see, at the most, what can you, so I always put this question, At the most, what can we do? 4, right? Is it 10? Yes or no?
Yeah, 10 x minus pi over 4
Mhm.
equals 10 x minus 1.
Oh, you are right. 10x minus.
No, it's still the same equation.
Oh, there's more there? Sure.
Yeah.
Why would they give like that? Oh, you're supposed to prove that. I mean, you
Yeah,
begin with the left, yeah. So I'll begin with this left. So this is the left part. So we'll begin the left, and we want to end up with the right. That's called proving. Why would the left equal the right? So first begin the left. So just apply the formula. What is the formula for tan of a minus b? What's tan of a minus b?
Would be
Tan
10
of-
a minus 10 b over 1 plus 10 a times.
Very good. Let's do that. So that's what you should know. You can't say I don't want to know. You have to know this.
I don't want to know.
Yeah. Okay, so tan of so which one is A?
X.
Okay, that's A, and that's B, correct? So tan of the first minus tan of the second, and 1 plus 10. Okay? A is x, so that's x, correct? And the b is pi by 4. And you already know what is 10 pi by 4 from there. You should know this. So the 10x stays the same. Then minus. Minus 1, right?
Yes.
And this 10x stays the same, and this will be 1, correct?
Yes.
So it's like 10 of x times 1. And finally you get 10 of x minus 1, 10 of x plus 1. Is this the right side? Okay. Yeah, and actually you are supposed to also, if they consider like a identity to be remembered directly. If this is x minus, right, and the main identity is if pi by 4 is written first, like you say. So if this is the case, you just have to swap the numerator and write 1 minus 10x, and the bottom part stays the same. I want you to write this in your notebook or somewhere, may take a note of that. This is very important. I think last class I forgot about. This is special case only when it is 45 degrees, okay? Not farther. There's no sign 45 type. It's only for this 10 pi by 4 or 45. If this is swapped, so this is x minus pi by 4, this is pi by 4 minus x. So if it is pi by 4 minus x, by later classes we should be just writing this identity. Remember it as 1 minus 10x, 1 plus 10x. And the other one is, if it is a pi by 4 here, and plus, you can prove this also, you can always prove this, 1 plus 10x over 1 minus 10x. So these are special identities, only for 10. And the reason is because 10, 45 is 1, right? So it's like easy to remember. Agree? Nobody's saying it. What about, go to turn the page, let's do faster. Now that we got a hang of it, why don't we do quickly? Jasmine, what's the next question?
So you have to prove the identity.
What is the left side?
Sin x plus y minus sin x minus y.
Oh, this is very important because we are going to prove something called defactorization formula. Let's see. This is helps us. There's another chart over there. We will see that is on Monday, not today. So is this fifth question?
Yes.
So say it again.
Sin x plus y minus sin x minus
Okay, sine of x plus y, and then
minus sin x minus y.
okay. do I, and you already know what is sine x plus y, right? Instead of that AB, what did they give us? XY. So all you think of this is like A, correct? Remember the second one is? B. Same thing here. This is like A, and that is, that the color coding helps this time? Okay, so let's start. What is the sign of the formula is? Sine A plus B. Go check the formula if you forget. What- Natali, want to try? Last time, they all did. Bianca did also, right? Jasmine also did.
I
No,
don't know how to.
try, no? Okay, go, Bianca, you finish.
Oh, wait, I finished it? I thought I was just gonna tell you what it was.
Oh, you want to tell? Valerie, you want to finish? On the board? You can. Just use that sin A cos B, cos A sin A, you know, that formula. Say, what is sin A plus B? Is it not sin A
Sine A
Cos B
times
plus cos A?
Cos A times sine.
Sin. That's all. So you know. I just want to get able to wipe off this. That's why. One second. It's dirty already. Sin A cos B plus cos A.
And then would it be, it would be twice because of this one too, right? So then it would be minus.
Yeah, you have to put a parenthesis, correct. You did a good job of putting, I didn't realize, because whenever there's a minus outside, it's always better to put parenthesis, right? Just come back. Oh, that's because, okay, one second, Valerie, sorry. Yeah, I think, I need to mark it. Can you write it again? Ah, you do. Are you finished? Okay. Correct, right? Is she correct? You said? You, when we came, how could you say correct? Okay, now let's do fast. So what I'll do is, I'll keep the first, this as it is, okay? This one, let's keep it, you can't do nothing because there's a, so there is a, outside, there was a plus sign, so everything stays the same. But because of this minus, you change the sign of the first term, that will be sine of x, cosine of y, and this minus and minus is plus. That's where students make mistake. So this will be plus cosine x and x sin, correct? So and you can clearly see one of those things, this thing and this the same thing, you can just cross it out, right? And this part looks same, so that will be, there are two of them, can you see this and this? There are two similar ones. So if there is similar one, so it's going to be 2 cosine of x. Is that okay? So what we prove is, I'm going to go backwards, you know, that's already the right side. But the right is, we proved a very important formula called defactorization. Now what is the meaning of defactorization formulas or identities? Is that you begin from the right side, it means it is 2 cosine of x and sine y. The answer is sine of x plus y minus sine of x minus y. So that's a special formula now. You should be knowing. Of course, right now you say, oh my God, how do we even remember this, Rebello? Yeah, I know it's hard. This is because you subtracted, okay? Just imagine if there was an addition, there's another formula that is 2 sine x cos y is sine of x plus y plus sine of x minus y. Is that okay? So it's kind of a new formulas called defactorization formulas. And you will also see, let's write those, all 4 of them, but on Monday we'll try to see in detail cosine x. And if there are 2 cosine, then you have to write cosine of x plus y plus cosine of x minus y. And if there is a 2 sine x and sine y, then this changes to first you subtract and then you add. So that's the only one looks totally weird or different. So you have to be careful with this. Is the only one. All of them has x plus y, x minus y, x plus y, x minus y, x plus y, x minus. The last one is you subtract and there you add. And in all these identities, there is always 2 times, 2 times, 2 times, 2 times. The first one is 2 cosine, sine, sine, cosine. I think I should have, this is the first, that's the second, that's the third, that's the fourth. Oh, we already proved those also. That is, if we had to start with this one with cosine here and a cosine there, with plus sign. Let's see, if it was this one, then you would have got 2 cosine of x plus y. Did you see what I'm doing? So a lot of options, like different ways to add and subtract. So this time if you have cosine and plus cosine, you end up getting that. That's why you see 2 cosine x cosine y is that same thing. There's no time to do it right now because, but still I'm just, that's the set of problem. Correct? So the homework, they give you only one problem, right? But there are 3 actually separate. Did they ask you another one then? No, see, they just gave you one, problem number 5. But 5 itself has got another 3 there. So the one that they give was with minus, right? They could have given with 1 plus. They could have given cosine and cosine with plus and cosine with minus, 3 more. But just to save time, we have to move on. Let's do, this is, how many minutes more?
3.
What the hell I'm doing there?
Just erase it.
Huh?
Just erase it.
Okay. So just want to show
Where is it? Don't erase the bottom.
which one?
The orange color.
Ah, okay. That was only if they had to give us that one, right?
Oh.
So if they had to give us cosine of x plus, cosine, what was that? I forgot. So cosine x, what I'm doing. This is the one, see? Cosine x plus y plus. So this is 2x cosine y. So if this was the case, okay, so we'll see that. So let me, before the bell rings, let's do the one, I'll start the first one. Here you go.
Yeah.
Can you tell me 6, what is given here? 1 minus?
1 minus tan x times tan y.
Times?
Tan y.
Oh, okay. Now they gave you something on the right, correct?
Yeah.
So at the most, all you can do is you write it as sin x over, correct? And this one becomes sin y over cosine. Can you write this quickly? Okay. And then remember, this is like a 1, right? So you want to have the same denominator for this side. So what you do is you multiply cosine x up, cosine y, and then also do the same thing. So why this orange color is multiplied and divided by here? So your question is, why did we multiply this? It's because, do you see this cosine x here? Nobody's saying yes or no.
Yes.
And that's why you have to do both up and down. Only thing, there are no numbers here, there are trigonometric ratios. So the denominator stays the same, which is cosine x, cosine y. And you need to be write down the top one as cosine of x, cosine of y, minus sine of x, and sine of y. And you know the answer, the top one? So the top one is cosine of x plus y. Done. Over. Yes or no? That's because this formula is, you undo the formula. Right? You learn something? Yes or no? Okay. So make sure come Monday we'll do a lot of this. Take care. God bless you.